Hi guys, welcome to Learning Electronics Repair. I have a motherboard here from a Lenovo laptop. You can see the board there. This is from a Yoga Slim 6. This model, you can see it here. And the fault on this was a charger port, USBC charger. So this was all full of green corrosion. I removed the old connector in the previous video when I found out what the fault actually was. And what we need to do now to fix this is to solder a new USB-C connector. I had one of these kits from AliExpress, which comes with like about 15 different types of USB-C connectors, and none of them fitted this board. And likewise, the guy who brought me this in, he also had a similar kit with less connectors, but it turned out that all the ones he had were effectively the same as the ones I had. I just had a few extra variations. So I found a listing on AliExpress for the Lenovo Yoga USB ports. It was a little bit unclear as to which of two types might be the one for my board, so I ordered a couple of each type, and then hopefully that means I can actually fix this. So this is one of the types. We see it here. Okay, that one. And you can see that the actual terminals are underneath. Okay, but this one looks like it has these sort of connected together. Yeah, it does. You can see that. Probably better under the microscope, actually. Yeah, so this one, now I have it. I couldn't see this very clearly on the photos on the AliExpress listing. It doesn't have them connected together. See, once I put it at the right angle, I can actually see it now. So that's that type. I have two of those. And this is the other type. So they're actually quite similar. Are the mounting points, these things in a different position, so where it mounts to the PCB? Let's have a look. Well, that's the two of them. Doesn't seem to be much difference. I'm not sure about this pin here. This one also has a pin there, so let's see if either of these will actually fit my board. Well, looking from the top, that's the one that's okay. That's the second port, and it was the same as that one, the one I removed. Here is a replacement. Okay. Let's see, and let's get one of the other type as well. Okay. Well, mine seems to be the most similar to this one. Well, this is a 317H. This is a 318H. So it's whether I can actually fit that in place of that. I don't know if this is actually like a model number or a date code. It's hard for me to say, to be honest. Well, it does have the holes there and there for the two pins I can see. And it also has like the offset pads in the right direction. So I think that's probably the right one. It's the closest I have anyway. Let's see. So this one actually has 4 mounting points there, yeah. I think what we'll do is first is see whether or not this actually fits on the board. I've made videos before on replacing SMD USB connectors and HDMI, but never one like this where all the pads are completely underneath. So how are we going to do this? I will say I've never done this before. Okay, this is the first time for me, so best way to learn, watch a novice doing it. I think if we add leaded solder, I think I probably did this when I actually removed it, but I'll add some more leaded solder onto the pads. I'll clean the holes out so I can get the socket to fit in. And I'll see whether I can actually solder the actual legs from the other side to hold the thing in place while we actually solder the connector. What I'll probably do then, in fact I'm sure I will do, is I'll take the preheater, I'll put the board on top of the hot air preheater to get the board up to maybe 120 degrees or so centigrade, and then come in with the hot air. And that should remelt the solder holding all these legs and solder the connector down. I'm working on the principle there'll be enough leaded solder on these pads already to effectively tin the connector, okay? Well, we can but try, I think. I have 2 of these, so I do have 2 shouts at this, alright? Let's go at it. Okay, so I have some flux. A bit of flux. I have a bit of hair or something in there as well. I'll just, get rid of that. I'm going to warm this up with hot air. Not enough to actually melt the solder. I just want to get a bit of warmth into the board, and then I'm going to get the soldering iron on here with some leaded solder, normal leaded solder. This will help to reduce the melting point, and that should make it easier when we come to solder the new connector on. So just clean up the soldering iron, my BC3 tip. The hot air's on at 450, by the way, full airflow. My T12 BC3 tip is set to 380 centigrade. So yeah, you can see that's tinning nicely because I actually got some heat into the board to start off with. I unsoldered this from the other side when I originally unsoldered the connection. Also as a connector to the port, so let's get some leaded solder. I can use that nice blob there and just drag it around onto the pins, okay. So I've got a nice amount of leaded solder on. Now I want to try and remove the solder from the mounting points where the actual frame of the connector goes through the board. So for this we'll use some solder braid. I use this one, by the way, guys, just show you that, this one. Chemtronics 8045. If you search for Chemtronics and then 8045 without the hyphens, the dashes, then that's the size I use. I get like a little tub with 10 of these in for about 20 euros or something. This is not the cheapest braid out there, but in my experience this is the best I've used anyway, and it's not stupidly expensive, so I'm very happy with this one. There was actually a guy on Bad Caps Forum some years ago who suggested I use this one because I was struggling with what I had, and it made all the difference, okay. So a little bit of flux on the braid always helps, and then let's see if we can clear the hole. If not, I'll go from the other side. If it still won't come clear, I'll use the vacuum desoldering tool. So let's go for this one. I'm trying to leave the solder on the pads as it is because I want some solder on there for when I attach the new port. So that one, yeah, it's not coming clean, you can see. I have a little bit on the grounding point there, I can easily clean that off. Not a problem. Well, I say not a problem, you get a bit of flux noise and a bit of heat into it. Okay, it looks fairly flat. So what's the other side like of this? Well, I actually desoldered this from this side, so you can see there's quite a bit of solder on here. Again, it's not cleaning it all out. There's some solder on this ground point. That's when I actually desoldered it. So I actually added some fresh leaded solder when I desoldered this. Okay. To make it easier for the same reasons. Lowering the melting point. So lead-free solder has a higher melting point than leaded. And when you add leaded solder, basically you're forming an alloy between the two. And you end up with an alloy with a lower melting point than the lead-free solder. Okay, so that's not coming clean. Let's try the vacuum desoldering tool. These desoldering tools, this thing, these make this sort of work much easier. In fact, some things are almost impossible. These will make fairly easy. So if you're serious about electronics repair, buy yourself one of these, okay? ProSkate SS311. Mine's actually a clone. This is a replacement handle for it. The first gun I actually managed to break. But yeah, this is something you should really buy. I'll be honest, one of the most useful things I ever bought. So to do this, firstly I'm just going to warm the whole area up. That makes it easier again. So once more, I'm not going to try and melt the solder. I just want to get a decent amount of heat into the board in this area. Get nice and warm. Okay, I'll probably, in fact I will add a little bit more leaded solder to each of the points I want to desolder. 1, 2, 3, and 4. Okay, and then let's get the desoldering tool. Okay, so hold it for a few seconds. There, you see. Again, hold it for a few seconds. I think it's actually clogged. I probably need to give this thing a good clean, actually. Let's see if we can do this job with it, though. Okay. Again, hold it for a few seconds. Yeah, didn't have that one. A few seconds. Got that one. This one. Got this one. So we'll just do that last one. Again, I'll just put the cleaning rod in here just to make sure it's actually clean. The one that hasn't unsoldered, the one that didn't unsolder, once again a little bit more fresh solder. And I'm going to use the hot air and the desoldering gun together. Just get the wires out of the way. So in fact we warm this up and then get the desoldering gun on at the same time. Okay. And that has it. So before I put this away, always clean it. Okay. And that should be fine next time you want to use it. Now let's see if the port will fit. These two very small holes I mentioned where the actual pins go through on the port, there's no solder in there, they're just holes in the board. They're not solder points, so that shouldn't be a problem. I have quite a bit of flux on there already, that's good. So here's my port. And that I think is sitting nice and flat. We'll get it under the microscope. Do we have alignment with all the pins? Yes, we do. Okay. I'm just interested to see if this will move much. In other words, can I actually move it out of line? Yes, I can. So I'm going to try to solder this down from the other side so it's actually in line, and then we'll get the preheater out and the hot air. This is on the basis that the solder in these holes I'm just going to tack it down with will melt anyway when I heat the thing up to a sufficient temperature to solder the connector down. Not done it before, so let's see how well this actually works. Okay. I think I'll actually just tack down 2 corners, not the whole thing. So bit of solder in that one, and we'll go for the opposite corner. Okay. Bit of solder in that one. I'll just check I actually still have it flat. Yeah, that looks like it's flat to the board. Other side. Just get a bit of light if I can. A bit of focus. Yeah, that looks like it's flat, and the pins at the back, yeah, they look to be perfectly lined up. I'm sure, as I mentioned, I can actually push down on the top of this with the tweezers once I get the thing hot enough to actually solder, but for now it's not going to go anywhere. So let's get the equipment we need, the preheater and the hot air, and let's see if we can do this. So here is my preheater, Carder 853B. I know some viewers in the USA say they can't get these in a 120 volt version, although apparently on AliExpress or elsewhere it says there are, but when they go they only find a link for 240 volts, so sorry guys, I can't really advise you on that one, but I'm guessing there must be similar products you can use. I've had this again for quite a few years, cost me about 40 euros, obviously we've gone up a bit in price since then. Bought it maybe around 2018 or 2019, but yeah, 2019 I bought this one, and this is also being invaluable. Now normally this can't actually get a board hot enough to solder from underneath, but what it will do is make a very good job of actually warming the whole thing up to 120 degrees or thereabouts, and then the hot air works much quicker and easier from the top. I'm going to put this sideways. What you see I've done here, I've just balanced solder and a little item so it's the right level. So I've just balanced this so this is basically level. Now, because this is a small area of the board, I may well get this up to a higher temperature than I normally can with this. So I'm going to take a little thermocouple, this thing. Couple of euros. I have 2 of these, they're really useful. Now I'm going to just put this on the board somewhere near to the connector so I can actually see what temperature I have. Just monitor what is happening with this preheater on this small part of the board. I don't want to get it to the point where it melts the solder itself. I'd much rather than hit the connector from the top. Okay, so let's set this up and then let's do it. Okay, so that's nicely warming up, 80 degrees or so. I can turn this up more actually. Let's just get the temperature a bit higher than that. If I can get it between 120 and 150, that's great, and then I'm going to come in with the hot air on top and just see if I can get this thing to like move around a little bit so we know it's actually soldering to the pads. So 90 degrees. Turn the heating up a bit more again. Okay, it's over 100 now. I'm quite happy with that actually. We can go a touch more. Okay, now let's get the hot air and see if we can get this thing to solder. So I'll use the hot air left-handed, so I'm right-handed. A bit of heat on here, and I'm hoping to see the solder melt at the back anyway. Let's see. temperature 150 something on the thermocouple. Bit more. Yeah, I can feel that moving around a little bit now, so I'm finally happy that actually soldered. I think we can actually see it change a little bit at the back. Okay, so turn the preheater off. I'm just on cold air now, cool it down, and hopefully that's got it. I think you probably saw it as well. I can see the solder change and effect at the back here when I think it's actually melted. Okay, I've cleaned this up. I have it under the optical microscope now. So this is actually the one that I haven't soldered. We can use this as a reference to see how it looks. I'll just make sure it's clear on your screen as well. The focus is slightly different on this microscope between the camera and the optics. Yeah, that's good. And this is the one we've just soldered. So that looks good to me. Let's get into shot for you guys a little bit more. Just again, just make sure the focus is exactly on that for you. There's obviously no way to visibly check if the other row of connectors have soldered, but I think we have to say with the preheater, we had a very even amount of heat going under there. We had the same amount of solder on the pads to start with, so there's every reason to expect they've soldered as well. So let's connect this to a PD power supply, and if it goes to 19 volts, so it's talking to the power supply, we can say with good certainty that the connector is soldered properly. If it doesn't, then we've got one of two problems, but let's have a look first to see what does happen. Maybe we don't have to go that step further. So I have my USB analyzer. I don't have the original power supply connected. I've tried that and I was getting nothing coming out of it. The same as on the original video. The connector on the original power supply is all green inside. It's heavily corroded. So I'm using another 65 watt, no, in fact 100 watt. This is the DJI one off one of our drones, but it's a standard USBC fast charger, okay, with PD. So let's attach this to our connector that we've just soldered and let's see what actually happens. Okay, let's go. And we do have some current going in. So there is a connection there, but it's not switching to 19 volts. Okay, I would expect that to switch to 19 volts. I mean, I don't have the battery or anything attached to it, but I don't see that would make a difference. I could be wrong, of course, but I honestly expect that would sort of go to 19 volts. I'll just connect the battery. So here we have the battery, the original one, attached. Let's try this again. So switch the power supply on. And it's gone to 20 volts. Great. So this is perfectly soldered. I'm happy. The fact it's communicating with the charger, that's absolutely fine. I need to put this back together, but you know what, guys? I'm absolutely confident that is working. There's no way the fast charger would go to 20 volts if the laptop wasn't talking to it. Okay, so there you go. That's how to solder one of those. Hope you like that, and I'll see you all soon. Well, A, in the comments below, because I'm sure you want to talk about it, and B, on the next Learning Electronics Repair video. Ciao for now, guys.